Have you ever looked up at a skyscraper and wondered how it stands so tall? Or maybe you've watched a house being built and marveled at the way it all comes together. Well, behind every impressive structure is a team of dedicated professionals called structural engineers. Structural engineering is like the backbone of construction. It's all about making sure buildings and other structures can withstand the forces of nature and the weight of everyday use. These skilled engineers use math, science, and a whole lot of ingenuity to design buildings that are safe, strong, and long-lasting. Think of it like this. If you were building a house of cards, you wouldn't just start stacking them randomly. You'd need a plan to make sure the weight is distributed evenly and the structure is stable. That's what structural engineers do, but on a much larger and more complex scale. From the tallest towers to the coziest homes, structural engineers play a crucial role in shaping the world around us. They're the unsung heroes who make sure our buildings stand tall and strong for generations to come. Now, let's talk about framing. Just like our bodies have skeletons to hold everything together, buildings need a strong framework to support their weight and shape. In residential homes, this framework is usually made of wood or steel studs, which are vertical pieces of lumber or metal. Think of them like the ribs of the house. In commercial buildings, especially skyscrapers, the framing is often made of steel beams and columns. These are much larger and stronger than the components used in residential framing, allowing them to support massive weights and resist strong winds. Imagine these beams and columns as the giant bones of a skyscraper. The framing is carefully designed to transfer the weight of the building down to the foundation and into the ground. This ensures that the building stays upright and doesn't collapse under its own weight or the added pressure of people, furniture, and everything else inside. Whether it's a cozy cottage or a towering office building, the framing is what gives the structure its strength and stability. It's the hidden skeleton that allows us to live and work in these spaces safely and comfortably. You might be surprised to learn that buildings are constantly engaged in a battle of forces, tension and compression. These forces are always at play, pushing and pulling on the structure. It's the structural engineer's job to make sure the building can handle it. Tension is a pulling force, like when you stretch a rubber band. Imagine a suspension bridge with its long cables stretching across the water. Those cables are under tension, pulling inwards to support the weight of the bridge deck and the cars driving on it. Compression is the opposite of tension. It's a pushing force, like when you squeeze a sponge. Think about the columns holding up a roof. Those columns are under compression, being squeezed by the weight of the roof pushing down on them. In any structure, tension and compression forces work together to keep everything in balance. The structural engineer carefully calculates these forces, ensuring that the materials used in the construction can withstand the specific stresses they'll experience. It's like a delicate dance between push and pull, and the structural engineer is the choreographer, making sure every element moves in harmony. This careful balance of forces is what allows buildings to stand tall and strong, resisting the constant pressures they face. Section 4. Shear and bending, twisting and turning forces. Tension and compression aren't the only forces at work on a building. We also have to consider shear and bending. These forces can cause materials to twist, bend, or even break. Shear force is like sliding your hands past each other while pressing down. It's a force that tries to slice or separate a material. Imagine a bolt holding two pieces of wood together. The shear force is trying to rip the bolt apart sideways. Bending force is what happens when you try to bend a ruler. It's a combination of tension and compression that causes a material to curve. Think of a diving board. When a diver jumps on the end, it bends downwards, with the top surface experiencing tension and the bottom surface experiencing compression. Structural engineers carefully consider shear and bending forces when designing buildings. They use strong connections like bolts and welds to resist shear, and they choose materials and shapes that can handle bending without breaking. These twisting and turning forces might seem small, but they can have a big impact on a building's stability. That's why it's crucial for structural engineers to consider every angle and ensure the structure can withstand all the forces it might encounter. Section 5. Standing strong. The impact of structural engineering. So there you have it. Structural engineering is the hidden force behind the buildings we use every day. It's the science and art of making sure our structures are safe, strong, and able to withstand the test of time. From the moment we wake up in our homes to the time we spend working in offices, shopping in malls, or learning in schools, we rely on the expertise of structural engineers. They are the unsung heroes who ensure our built environment is a safe and secure place to live, work, and play. As we move towards a future with even taller skyscrapers, more innovative designs, and a greater focus on sustainability, the role of structural engineering will only become more vital. These skilled professionals will continue to push the boundaries of what's possible, creating awe-inspiring structures that stand as testaments to human ingenuity. So next time you walk by a building, take a moment to appreciate the work of structural engineers. They are the ones who make it possible for us to live and work in these incredible structures, shaping the world around us one building at a time.